Ready, Summer? You don't have your paper.
Yeah.
Where? Come on. What?
What?
Huh? Ni hao? No. What are you talking about?
Oh. Because.
As it Lauren, the chemistry teacher.
Yes, I know her.
Yeah, she was excited. I have some stuff to do, like message, because about rent transfer. My friends asked my bank account, so I was doing that like kind of emergency. So I was and she talked to me after class.
You're in trouble.
Yeah.
Yeah. You should be a good student. Is the emergency over? Problem fixed?
Yeah,
it's fixed. Okay. Well, that's good. That's good. Okay. If you can write this down, kinetic and potential energy.
Okay.
Yeah.
Do you have Khalifa on WhatsApp?
Yeah.
Do you want to send him a message? Ask him where he is.
Okay.
Say, hello Khalifa, Happy New Year, where are you?
It sounds like you. I don't know what to say, but happy birthday. The last message I sent to Khalifa is Colin needs you back.
Oh, I see. Okay.
Yeah, so if you send that, that's fine. Did you find Khalifa? Someone?
Yeah.
Okay.
Maybe I can send a message to.
Yeah, just to see. Maybe he had to go.
Where?
Wait, is that him? It is, Khalifa. Come in. We were wondering where you were. What happened to you?
Neil called me.
Oh, you were with Neil. Problem?
Yes, no, yes.
How about
Like chemistry.
Chemistry problems. Everyone has this
I
one.
hate chemistry.
Yeah, it's wrong.
Tough, huh? Have you studied it before?
Yes, I wasn't because I hate it. I didn't pay attention to it.
I understand. Alright, we'll start now. Khalifa's here. So, kinetic and potential energy. Gao, would you write that down?
Yes, sir.
You got that? Come on, yeah.
Sorry.
Oh yeah, thank you. You were texting Khalifa. Now, let's see. Okay, Khalifa, so you don't say, because you might know because of your English. Let's see if these guys remember. So what type of energy is kinetic energy? Don't look.
Like something.
Yeah.
Elastic.
Huh?
Elastic.
Nope, not this one.
It can do some work.
Because?
It has some energy.
Yeah, but why? What's it doing?
From the
No.
Can move.
Kinetic energy is energy because of movement. Because it's moving. Yeah? Remember, like the man running. And what's potential energy? Yeah. Potential energy because
It's nearly move, almost move.
almost fall.
Almost
Yeah.
fall.
Okay, good. Right, so let's continue then. So, we have a couple of formulas to look at today. Yeah, we're going to have a look at these formulas. So, if an object is moving, then it has kinetic energy. This energy is from some work being done on the object. That is, kinetic energy equals the work done to give it that energy. You don't need to really write this down for the moment. So if a mass m is moving with speed v, then how much kinetic energy does it have? So this part you do have to write down. So just think about it like this. Don't draw this just yet. I just draw this first, okay? But don't draw it just yet. So this M is moving with speed v, and we say that this has energy, okay? And the reason it has energy is because it could hit something and do some work, okay? Now the work that it could do would equal to the energy it has. Remember, this is conservation of energy, remember? But where did it get this energy? It must have got this energy because somebody, you know, they threw it. So they did some work. So they did some work, they threw this, it gave it energy, and then this energy could go do some work again. Okay? So in other words, the energy it has here is equal to the work taken to give it this energy. Okay, so now let's calculate that. Alright, so now you need to write this part down. So it starts at rest. The V we don't know. The A we don't know. T we don't know. Oh, sorry, the V we do know, sorry. The A we don't know, the T we don't know, and the S we don't know. Okay. The only other thing that we know is its mass. We say we know its mass M, and we'll know its V here. Okay. So let's use the formula here to calculate kinetic energy. So the kinetic energy should equal the work. And what's the formula for work? Yeah, force times distance. Yeah, yeah. But what did Newton say the formula for force was? Ma. Okay. Now, do we know the A? No. Do we know the S? No. But if you look at this formula, V squared equals U squared plus 2AS. Do we know the U? We do. What's the U? It started at rest. So you have V squared equals 2AS. So what does AS equal? V squared over 2. You can put that back in here. So you get now kinetic energy equals M times AS, which is V squared over 2. Or in other words, the famous formula, a half M V squared. That's the formula for kinetic energy. You've probably have seen this formula before.
Yeah.
This is the proof of it. Have you seen the proof before?
Proof.
Yeah.
Yeah.
But
But we didn't use the KE. Yeah.
What letter do you use?
I forgot
P?
P?
No, it's
Yeah, probably B. Yeah, that's the other letter. I don't like to use B because then there's too many V's. Yeah, so yeah, a lot of books use this for kinetic and this for potential.
Potential? Yeah. I
V and T.
Yeah.
But I don't like that. I like to use KE and PE for kinetic and potential energy.
So in Ireland, people will use the KE.
No, they use T and V, but I don't like to use T and V.
Okay.
Yeah. Oh no. You can ask him something in English.
Okay. Sorry, if I leave here at 4, should I send email for absence, or I just tell you leave?
You need to. Is some problem?
Oh, festival.
Maybe it's a.
But then if you want to leave at 4, they'll want to leave at 4 as well.
No, it's,
No.
I'm
no,
good
sorry.
student.
I may have a lot another students in PMP. They already leave send leave request. So
Yeah, just send an email before you go, okay?
4 class equals Chinese 12
yeah, 12
Yeah.
p.m. is really important.
It's
12
12
It's
o'clock.
jack leg for 4.
Mm,
Is
Mm.
equal 0. 0 a.m.
I understand. So what are you going to do?
I'm going to Tom, like, I don't really want
Celebrate.
Okay.
to. So I,
Happy.
Are you going to stay?
No. What?
no, you will stay here.
I will stay here. Yeah.
Good, okay, alright.
No
That's fine, just email your tutor, okay?
Also, I don't have to send email.
tutor.
No, do email your tutor.
Only tutor and manager, new and color.
Yeah, okay, yeah.
And
Well-
absence? So I always send like 3 email and.
Yes,
Teacher.
the tree, yes.
Okay.
You don't need to email me, that's
Yeah.
okay.
I'm sorry.
Yeah, that's okay. Because you told me. Alright, continue. You have this formula?
Yeah.
KE equals a half mv squared.
Yes.
Yeah, okay. And you've seen this formula before. So, let's see. Right. So we've just worked it out, a half mv squared. Now, if an object is a height h above the ground, then it will have potential energy. It got this energy because somebody did some work. That is, a force brought it to that height. So, again, repeating the process, let's see what we can get, okay? How much potential energy does it have? So, it's the same logic here. Imagine that this mass is up here at the top of a building or something like this, okay? This can do some work because it could fall down here and apply a force and do some work. So the work here is equal to the potential energy it has. Why does it have this energy? Because somebody must have moved it up to here. So somebody gave it some, or somebody did some work to it. Okay? Now, what is the formula for work? So potential energy will equal the work done, and the work equals the force by the distance. And the distance here is h. But what is the force that the person gave it? We actually know it. If this here is mg, then the person must have had a force of mg upwards, so that they could move it up at a constant speed and put it here. Yeah or no? No? The weight is mg. So the force that the person must have pushed with equals mg to cancel the weight. Yeah, someone? Are you sure? You don't look happy. What are you thinking?
Maybe he must use
More. If he uses more than mg, it will accelerate and have kinetic energy. Remember, Newton said if there's no forces, it can move at a constant speed. So that's okay. So the F is mg. So we get our formula mgh. So potential energy is mgh. So if we can write this one down now.
But I confused this picture.
Yeah.
The edge, the top has a mass and base.
Yeah.
And someone in the bottom
Yeah.
throw the
No, not threw it. Carried it.
car.
Carried. Walked.
A walk.
Like-
Car carry.
Yeah, maybe like it's a ladder.
Oh.
Something like this, yeah. Not throw.
Oh.
Sorry.
Okay. It is P.
PE. Potential energy.
So I remember something is P.
What was FH again?
Huh?
FH.
FH. Force times height. Did you send your email yet, Go?
Yeah, I'm sending.
Not sent yet.
No. Thing is, before I leave here, at least 1 hour here,
More is better, but you should send it before you go, not after you go.
Yeah, I'm sending.
Yes. Okay, did you write this down?
Yeah.
Everything? No picture? Okay. No picture, fine. You got this, Khalifa? Yeah?
So the picture are you confused?
No, pictures help you. Okay. Right, so, Summer, what are you doing?
Logging my WeChat. Logging.
No, don't log into your chat. We're doing physics now, come on.
Okay.
What should I say? Today's holiday?
Today is
literally, oh god, I feel so bad.
Uh,
Sorry.
Say,
today is
dear staff.
Dear staff?
Well, what are we going to say?
Hi.
Hi! No,
Yeah,
no, no,
yeah,
no,
yeah,
no,
it's
no, no,
fine.
no, no. Say, dear staff.
Dear staff.
Yeah.
Today is
S-T-U double F?
No, S-T-A-F-F.
Sorry. Okay.
Yeah, yeah. I am very sorry.
apologize.
For the listener,
No, let's not confuse things.
Sorry.
I'm very sorry, but I will miss class at 4 p.m.
Yeah.
Why are you missing class now? You're going to some party, is it?
Chinese.
No, it's, yeah, like festival. Family festival.
I have a family meeting at this
Okay.
time.
Yeah, okay. Meeting at this
Thank you. Thank you, and then put your name and send it.
Okay.
Yes, lots of
Lots of love, go.
experience.
Okay, continuing now, go, you ready?
Yeah.
Alright, so because the next thing is important here.
Okay. Camera draws.
Absence excuse.
What?
Absence excuse.
Absence excuse, yes?
Absence request. No, least request. Leave. I
That's
got it
fine.
wrong. I got it wrong.
Doesn't matter, doesn't matter.
Least.
Oh, people are calling me. Right, okay, continuing?
Yeah.
So look, the potential energy is interesting because kinetic energy can't be negative because the formula is a half mv squared. Yeah?
Yeah.
So can m be negative? No.
No.
And v squared? No.
No.
But potential energy can be negative, and what's very interesting is it has a different meaning. So the first one is the easy one, if potential energy is positive. So we say the object has potential energy, and let me show you what that means. I'll draw it in a picture here. So here's the ground.
Yeah.
If something has potential energy, so like it has he's fallen.
Wow.
Looks
This
funny.
potential energy is positive. So it has energy. It could do work. The usual story here. So if potential energy is positive, then we say it has potential energy. Now, what's interesting is if potential energy is zero. So what does that mean? Well, that's if it's like this on the ground. Okay? That's potential energy is zero. We call this situation free.
Situation.
Yeah, it's free. This person is free.
Yeah.
Here, he's not really free. He can't quite move anyway. But here he could move left, he could move right. You know, it's a free person. So if the potential energy is zero, we describe it as it being free. You got that?
But potential energy is not moving.
If it's moving, it can have kinetic and potential. It can have both.
Okay.
So yeah, I know in this picture here, this man has kinetic and potential in the first picture. He has both, yeah.
But the second picture had potential energy.
No potential energy. The height is zero.
Oh, so potential energy always in the vertical.
Yeah. Oh yeah, yeah, yeah. Okay, is that okay? You have that? Yes? Okay. The last one. Oh no, you're still writing. Summer, did you write this?
Yeah.
Yeah, okay.
Yeah.
What did you write?
If P is
More than zero.
more than 0, then we say the object has P. If P equals 0,
Yeah.
then we say the object is free.
Good, okay. And then the last one, if the potential energy is less than zero, then we say the object is trapped in a potential well. Now, you can continue writing that in a moment. I just draw the picture. Trapped. Potential energy is negative. The reason we describe it as trapped is because if he wants to be free, yeah, he has to come out, we have to give him energy. So like here, he has energy. Here he has no energy, potential energy, so we say he's free. Here we say he's trapped, because we must give him energy if he's to be free.
Right.
So, the last guy we described as being trapped. Do you know this word? Like stuck.
Yeah.
Mm.
Yeah. In what we call in a potential well.
Person have his own.
Yeah, so he has to use that energy to be free. So, you know, energy from breakfast or something, it has to be used to be free. Yeah? Yeah. Now, you've seen this in chemistry already. Have you done ionization?
Yeah.
So, you know, the electron is in orbit.
Yeah.
It's trapped.
Yes.
And if you ionize it, it's free.
Okay.
So you ionize it by giving it energy. So we actually say the electron had negative potential energy. Yeah?
Electron?
Yeah, yeah. So for example, in chemistry you have your proton and your electron.
Yeah.
And you ionize it means you make this guy free.
Yeah. Electron gone.
The electron's gone. It's free. It's left.
Yeah.
To make it free, you have to give it energy. So maybe like, I don't know, you heat it,
Yeah.
or you
use the
do
gun
something.
shoot.
Use the gun to shoot at it, yeah. Something, right? So this is actually trapped. It's trapped around the proton. It's trapped. It's not free. It's stuck.
So in orbital contract.
Yeah, in orbit it's trapped. And we say the potential energy is negative. So when it's in its orbital, we say it has negative potential energy. It's trapped in its orbital. It's not free, it's trapped. Okay? So my point is, it's okay. You can have positive, zero, or negative. They all have a different meaning. Yeah? Now that's important. That's very important, actually. And I already looked at an example. So do you have those three situations?
Yeah.
Yeah? Okay. Right, so the conservation of energy tells us that the energy at the start equals the energy at the end.
Would I do that?
No, I think what the next part you might have to write down, I'll give you a box. So, remember we said you can't change the energy? So if you write that as a formula, it's energy at the start equals energy at the end, which means kinetic at the start plus potential at the start equals kinetic at the end plus potential at the end. Yeah. So this is we did this last time. Remember we did this last time?
Yeah.
I said it's the most important rule in
Okay.
physics. This is it as a formula. You can write this box down
Observation.
of mechanical energy. Okie dokie, you got that?
Yes.
Yeah? Continue? Good, okay. Maybe I have an example. Right. Here's one we can do this together. You have 1 kilogram and you lift it to a height of 10 meters. How much potential energy does it have at the beginning? So what's the potential energy at the beginning? So that's mgh. So let's calculate that, okay? Give me the answer for the first part. The potential energy, what's that? So what's the formula?
P.
No, for potential energy?
P.
98.
Yeah. mgh, yeah.
Half. Nine.
No, the other one. Potential, mgh.
Oh,
mgh. Yeah? That formula, yeah?
yeah.
So what's the m?
It's
1. And what's the g? 9.81. And the h? 10. So what's the potential energy?
It's
No, 98, what you said, 98.1 joules. Okay, so if you can write that down.
It's not minus?
It's not minus. Not minus.
No, because you lift the ball up and it's here. So remember we said this is positive.
Oh, dropped.
Dropped. We're dropping it. So right now, everybody look, the ball's up here and it's going to be dropped. It has potential energy, 98.1 joules. Okay.
So it's displacement. It's not minus or.
No, it's right at the beginning. It's here, ready to start.
So it's start falling down is minus.
The h, is it?
Yeah.
The h is always positive because it's the height. So it's not the. How can I explain this? The s is negative because it falls 10 meters, but the h is positive because you measure the h from the ground up to it. That's 10.
Okay.
This is h and this is s.
Okay.
It's a little different. I understand why you're confused. I understand. The h is positive. It's 10. Yeah. Okay. Next part. Part B. How much kinetic energy does it have at the beginning?
Half 980.
At the beginning, what's its kinetic energy? What's the formula?
0.
What's the formula? Yeah,
0.
it's 0. A half m v squared. Yeah? A half m v squared. 0, because at the beginning it's at rest.
Yeah.
Okay. So tell me this, what is the total energy at the beginning? The total, the kinetic plus the potential, what's the total at the beginning? 98.1, yeah, 98.1, okay. Part C, how much potential energy does it have right here, just before it hits the ground? What's the potential energy here?
It's
Well, what's the formula? mgh, yeah. And the h is 0. So, just before it hits the ground, right here, it's 0 potential energy. Okay?
Yeah.
Now, how much kinetic energy does it have?
It's
Yeah, you don't know V, but you know how much kinetic energy it has.
MGH is same
Yeah.
as MGH.
It's the same.
Yeah.
It should be 98.1.
Yeah.
Because when it was up here, the total is 98.1. When it's down here, the total is also 98.1.
Energy is not on this.
Yeah, the energy doesn't change.
Yeah.
So if the potential energy here is 0, then the kinetic must be 98.1. It has to be. Because the total here has to equal the total here. So look, if I draw the picture, look here. Here's the ball. Its kinetic energy, 0. Potential energy, 98.1 joules. And total energy, 98.1 joules. When the ball is here, potential energy, 0. Total energy must be 98.1. Because the energy we said is the same at the start and the end. Therefore, the kinetic energy has to be 98.1 joules.
T.
Total energy.
Oh, cold.
Yeah, sorry. E. Just E. E.
No, no, no.
Okay, okay. Is that okay?
Yes.
Let's look at another one.
But
Yeah? What?
we finish
Finished.
3.
Yeah, the whole.
Yeah, this one is 0 and this one is 98.1.
Yeah,
So,
this one. Yeah.
How much free does it have? As
0.
a moment of impact.
yeah, that's here at the ground.
Why he doesn't say in here?
Yeah, at the
It's
moment of impact.
It's
At
no
the
normally.
moment.
At the moment of impact means right here before it hits the ground.
Yeah.
Just before.
Means
Moment of impact means this point here. Yeah? Is that okay?
I don't know this.
This word here?
I
Impact.
I know this. I just say I don't know this before.
Okay.
Now I know.
You know? Okay. Continue? Okay. Right, here's an example. A 200 gram bullet is fired horizontally from a height of 10 meters at 100 meters per second. So I'll draw the picture here. Here's the ground. Here's the bullet. It's fired at 100 meters per second. And the height is 10 meters. And its mass is 0.2 kilograms. Okay? And what happens? Well, it comes along and then it hits the ground. And my question is, what is the speed here? How fast is it going when it hits the ground? Now, we actually did this question in projectiles with the car that drives over the cliff. Remember this one? But you can do this a lot quicker if you use the formula from today. I'll let you try it for 1 minute to see if you can figure it out.
1 minute.
Okay, maybe more than 1 minute.
So straight.
But you're very smart. A very smart class, so it's okay.
In the beginning, the K is 0.
The K?
KE.
Oh no.
Yeah, it have the.
It has kinetic energy, yeah.
But in the
And?
in the end, it just have the KE.
Correct.
Yeah.
Yeah.
Oh.
You got an answer? Good. Let's see if you're right. So, at the beginning, what energy does it have? It has two types of energy. It has kinetic and potential. So let me just think about it like this. If I draw a line here, start, end. Okay? We have kinetic energy, which is a half m v squared. What did you get here, Gao, for this? It's 1000, 1,000 joules, wasn't it? Is that right?
It's
A half?
it's 100 joule. It's 100 joule.
100 joules? Or 1,000 joules?
0.2.
Yeah. Divide by 2.
4 Oh yeah, it's a 2. 1,000.
Am I right?
Yeah, it's
Okay.
right. It's right.
10,000.
10,000. 0.2. Half
0.2,
0.2.
Yeah, it's okay. All right. Now, what's the potential energy? That's M G H.
Yeah.
So what's that? 19.
0.2 mg and
Yes, 19.62.
Yeah.
Is that right?
19.6, yeah.
19.62.
Yeah.
Okay. So what is the total energy? That's 1019.62 joules.
Yeah.
Now here, the potential energy is 0 because it's on the ground.
Yeah.
And the kinetic energy is a
half
v squared.
Yeah.
But you know that the total still has to be 1019.62. So that's fine. That means then that 0.1 times v squared should equal 1019.62.
Yeah.
So that means v squared
is
1019.62.
Yeah.
So then v is square root of that.
Yeah.
So what's square root of 1019.6.2?
100.97. So it's like
101.
not the one.
So not 40.
No.
So what was your mistake?
No, I forgot. I don't know why. Maybe so we just finished the example. So
You forgot one of these?
no, I make kinetic.
Yeah.
Kinetic to 0
Here.
in the start.
Ah. Definitely not 0.
Yeah.
Yeah, okay. Is that okay?
Yeah.
Yeah? Continue?
Yeah.
Yeah? Okay. So let's see. A block is placed on the top of a wedge at 30 degrees. The longest face is 2 meters. How fast is the block going when it reaches the bottom? Okay, so I'll draw it for you and you can try it. You have a wedge. This is called a wedge. And this angle is 30 degrees. And the face, that's this side, that's 2 meters. Okay? And you put a block here. There's the block. And the block is, you don't know its mass. And it slides down and it hits the bottom. And again, my question is, what is the speed here? What's the speed here? Okay, I'll let you try this.
It's rise, rest, beginning.
Yes,
Okay.
So it's 0, isn't it?
0 at the beginning. Yeah,
Can,
correct. Kinetic energy is 0.
How
And of course, everything here is smooth.
M is.
Don't tell you.
Don't tell me.
Don't tell you the M.
What?
Not important.
Okay.
you can cancel that.
Yeah. Yeah.
So my sine 30 is this.
That's terrible. Buy a new calculator.
Okay.
You need to. It's terrible. Did you get a calculator, Khalifa? You have one?
So I can I use stupid.
Give me. Let me see that. Let me see that. You're so much trouble. Do you know? You're so much trouble.
Yeah.
4.4. 4.4.
Joules.
Joules. I was in German. The station. Joules.
There, I fixed it for you. Summer.
Oh.
Okay.
But
What?
it's also
Well, that's right.
oh. How to get that?
I fixed it. I fixed it.
Thank you.
Okay, you ready for the answer here? No? Okay.
So the H is 2 sine 30.
Sorry, part 3? Oh, maybe
let me do it. So, look, this side here
Oh.
is 2 sine 30.
1.
Yeah, which is 1. And this side here is 2 cos 30.
We need cos.
Is,
No, I'm just saying.
4.
So the height is 1
44,
meter. So here, this guy has only potential energy.
Yeah.
And here, this one has only kinetic.
Yeah.
So a half mv squared equals mgh. So they're gone. So v is square root 2gh.
Yeah.
But we said the h is 1.
Yeah.
So that's square root 19.62, which is 14.
4.43.
4.43 meters per second is the answer. Yes, good.
This is
Very useful formula. Very useful formula, isn't it? Okay, I think, is there more examples? No. Okay. So, no pictures in this one. Right. Alright, so what time are we at? Okay, so for a few minutes, can you try these questions? You can see they're not too difficult. What page is that now?
14.
Ah, yeah.
14.
40. You keep mixing this up. 44.
No, 14 4.
Yeah.
14 is
40.
Yeah.
20.
Yes.
30.
Yes.
30.
30.
Ah, that's fine, yeah.
13 is 1.
Did you hear the
No.
What?
Maybe you call in whole day so your ear has some problem.
What?
So we called, both of us is called like, we do call with family whole day today. It's really important.
You
So your
accept.
ear has some problem.
You see the alien.
Perhaps. Perhaps he's going crazy.
Yeah.
Alien
Perhaps
size.
Psycho.
crazy.
Psycho, yeah.